Guys, all on this page in your notes. If you're not, go ahead and get there. I would like for you all to try number 3. So kind of give us a good gauge on how much you're remembering from the video. So please do give that a shot. If we're up to about 80-something% of the video right now, so that's decent. If you forgot or whatever, you can always do it for late credit. Whatever.
I watched it, but I forgot how to do it.
That's why we're doing this. I want you to try number 3.
Because I watched it
Try number 3. It works great. Great. It doesn't.
I watched the video like 2 hours ago. Is that a problem?
Just had to watch it by the start of class. Just by the start of class. So I did a little screenshot basically, like a minute before class started. I don't know. If you watched it before class, then yeah, you should be good. Yeah, 'cause I set it up for 7 a.m. So what I'm telling you is I take a snapshot of it right before class starts. So if you watched it before then, you should be good. Yes, ma'am.
Or is that not how you do it?
I think that's right. That's right. How we doing? Okay, I'm going to show you. I'll show you here in just a second. Okay, ladies and gentlemen, here's how this one would work. When you are multiplying two radicals together, what you do is you multiply the radicands together and leave it in a square root. So we're going to multiply the radicands together. So 14 times 2 is 28. A times A is A squared. And because they were both square roots, it's still a square root. Okay? Once you've gotten to this stage, all we need to do is try to simplify the radical. And so what we'd want to do is try to break down the 28 and the A squared into prime factors. Should break down relatively easily. 28 is 2 times 7. And A squared is just A times A. So like we've been doing since basically the start of our unit, we're going to be looking for pairs of like factors. So I would say that the 2's are like factors. The A's are also like factors. So if you've got two 2's on the inside, it shows up as just a single A on the outside. And same rule with the A's. If you've got two A's on the inside of the radical, it comes out as just a single A. So it'd be 2A, and then inside the radical there was a 7 that didn't have a pair, 7 to pair with, and so it's left inside. 2A times the square root of 7 would be your final answer there. How are we doing?
Good.
Any questions? Yes, ma'am.
This is kind of like a general thing, I think. So whenever we get like the 2A or like anything and then root of like 7 or root of 3 or whatever.
Yep.
Why don't we like do it?
What do you mean do it?
Like do the root, like square root the number.
Oh, you mean approximate it? With a calculator maybe?
Yeah, we'll like do like the square root of 7.
What is the square root of 7?
I don't know, like 3.5 something.
It's probably like, have to be 2.7, I'd bet. 2.7 ... But Grace, the point is, Grace, you could. It didn't ask us to approximate anything. And so like anything we would do with the calculator would definitely be an approximation. That is actually an exact answer.
Okay.
So that's technically, I'd say most mathematicians call that better.
Okay.
A decimal could be useful in a certain context.
Okay.
All right. If you have not already moved on to number 4 or number 5, please try both of those. Try number 4 and number 5. And we'll check and see how you're doing here in a second. And if all is well, we'll head back up to the board here in a little bit. One of them you might have seen in another class, or you might have kind of gotten there intuitively. So here would be one way to do this. You could look at number 4 and you could say that a square root and a squared undo each other. You could very easily do this and say, well, this square root and this squared would essentially cancel each other out, giving you 15. And 15 would be a good answer here. You could have looked at it differently, though, right? You could have said, well, squared means times itself. So you could have gone this direction and said, well, this is really square root of 15 times the square root of 15. And whenever you're multiplying two radicals together, you can just multiply the radicands together. And 15 times 15 is 225. And the square root of 225 is 15. So no matter which way we went there, both of those are valid ways of doing it. The answer there would be 15 in the end. Any questions on number 4 before we move on? Okay, fair enough. Then number 5 says Multiply, then simplify. So what I want to do here is point out the nature of these numbers. This number right here, the square root of 5, is in a radical. And these two numbers, not in a radical, right? You got a 12 times square root of 5 times 4. So if you've got two factors that are in a radical, you can go ahead and multiply those together and leave them in a radical. We've done that already. If you've got two numbers that are not in radicals, you can multiply those two together as well. What you can't do is you can't multiply a number that is in a radical times a number that is not in a radical unless you take some extra steps. So what we would do here is recognize that the 12 and the 4 are both non-radical numbers, and we can multiply those together just in the normal way that we've always multiplied things together. So 12 times 4 is?
48.
48. And the square root of 5 does not have a radical to multiply by it, and so you'd be left with 48 root 5. 5 is prime, and so there's no simplifying to be done with that radical, and we'd leave that one alone. Okay, so you've had a chance to look at 3, 4, and 5. Do you have any questions? No? Stretching? Any questions at all? Okay, well, let's head to the board. Let's do a little bit of practicing up there, and then we'll come back and finish this up. Okay, ready to go. Square root of 5 times square root of 10. Got it? Once you think you've got it, there we go.
You're really, really funny.
Connor, you got it. Nice job. Luke, nice job.
What? Okay, so it's 50.
There we go. Got it. Got it. Good. It's a good start, Lana. Keep going. Yes. Lana, you're not wrong. You're just not done. You're just not done. That is right. Yep. So, Gracie, you're not wrong. You're just not done. That can be simplified a little bit further. You fixed it. Good job. There we go. I like your work there. That's good. Okay. Doing okay? Looks like we are. There's some work up there if you want to check. Look good?
Well, I just don't understand why you have to make it 50 first. Like, you get the same answer
Yeah, there's more than one way to do
if
it.
you had just done 5 and then 10.
I don't know what you mean by do 5 and then 10.
If you had just done and gotten 5 and
You could do it that way too. You could do it that way too. I don't know that one's faster than the other, but you could do it either way. Okay, let's head back up. Let's try another one.
I don't even know how it goes. Where'd it go?
Ready to go. Got it?
What is 5 plus 3?
Got it. Good job. Got it, Joel. Be careful that your exponents and everything are on the proper level. Be careful, like, It looks like your 4 is on the same line. It's like, just be careful. It's easy to do. Good job.
There you
go.
We can't do it, it's impossible.
Why is it impossible? Well, you know, this is where it'd probably be better to do it the other way. Multiply first. There you go. You got it. That's nice work. Ashley, that looks good. Yeah, good job. Who's doing well back here? You know what you need to do? You need to multiply first.
Rosanna, you already have an answer.
Like multiply your radicals together.
got that. Oh yeah, I need to go back.
You need to multiply your radicals together first. Multiply before you start breaking it down.
Honey, it's a square root.
Yeah, we know.
Oh, but you don't have it in a square root. Oh.
What goes in the square root though?
The 5 goes
Just the
inside.
5. Yep.
Yeah, I had that. I just had a moment though.
It happens. It happens.
Wait, so this would be 2x, and then 2x would it just be 4x?
Not 4x, x to the 4th. Because out here it's not, these are not being added together, they're being multiplied.
Yeah, I forgot that. So it'd just be x to the 4th and 5.
Yep. Hey guys, let me get your attention here for just a second. The only thing that I'm seeing here that's, I'm seeing a lot of good work. The only thing I'm seeing that's an issue is maybe just getting things a little bit out of order. I think your best bet is to go ahead and multiply the radicands together first before you try to simplify. You can do it either way, you really can, but I think it's easier to probably multiply it together first. So what I would do here is multiply my radicands, put them in a radical. It'd be 5x to the 8th inside the radical. And at that point, we could break that 8th power down. We'd end up with x to the 4th times square root of 5. The 5 would not have any like factors to pair off with, so we'd be left with that right there. Okay? So again, saw lots of good answers, but I saw maybe the ordering was off a little bit. So let's be careful that we multiply first and then simplify in the end. Fair enough? Okay, let's head back to your seats. We're going to do a couple of more items in your packet. Okay. So if you guys would, check this one out with me. We're going to do a few more here, and then we'll be back at the board. I don't know. We'll probably go over your quizzes. We'll see how the timing all works out. Okay, number 6, 2 root 7 times 3 root 6. So this is where it's really important that we distinguish between factors that are radicals and factors that are not radicals. So as I look this through, I see that I've got the square root of 7 and the square root of 6. Both of those numbers are radicals, right? They're, the 7 and the 6 are radicands. They're inside a radical. However, of course, the 2 and the 3 are not. So those are non-radical numbers. So what I can do is I can multiply numbers that are non-radicals together. So I can multiply the 2 and the 3. 2 times 3 is 6. And root 7 times root 6 would be the square root of 42. So you see how I multiplied the non-radical numbers together, and I multiplied the radicals together as well? Our final step here would be to break the 42 down and see if it can be simplified. Can anybody tell us the prime factors of 42?
6 and 7.
So 7 is prime, but 6 is not. 3 and 2, yep. So when you look at this a little more closely, when you break things down, you can see that there are no pairs of like factors that can come out. And so really the 6 root 42 is the simplest possible answer. Okay, any questions? Okay, so then let's do our last one here in this little section. See how all the timing stuff goes. Let's take a look at number 7. So number 7 is the square root of 7x plus 9 squared. And kind of like we did before, it's a little more complicated, but kind of like before, I'm going to show you a couple ways you could do this. Here would be way number 1. I like this way a lot. How does a radical play with a squared? How does a square root play with a squared?
They cancel each other.
They don't play very well, do they? They cancel each other out. So if you wanted to, you really could look at this and say that the radical and the squared cancel each other out. because they are inverses of each other. And so this would give you just 7x plus 9 for a final answer. And if you did something like that, it'd be totally fine. A lot of pitfalls here that you want to be careful of. Here'd be another way to look at it. Squared means two things being multiplied together. So you could write it as 7x plus, square root of 7x plus 9. Listen, please. Times the square root of 7x plus 9. This would give you the square root of 7x plus 9 times the square root of 7x plus 9. Guys, listen up, please. And like we've been doing before, I've got two factors in there, two prime factors, and we're looking for pairs of like factors, and there's two like factors right there. So if you've got two like factors inside, they come out as just a single. And so then at this point you could say, well, this just simplifies down to be 7x plus 9. I really think this is a better way to think about it, simply because it's faster and more efficient. Get you to the same place, still makes sense. You can do it the other way as well. It should be fine. Okay, I think I was planning on going a little bit further, but our fire drill was a little bit long, and so I think maybe that's where we'll stop as far as moving forward. Let's go to the board for a few minutes here. Let's do a little practicing with this, and then we'll finish off with your quizzes.
What is wrong with Who? I know. What do
I'm moving, and you can say please. We'll tell you. Not
All right, there you go. Got it? Good job, cool. Here we go. Here we go. Yep, got it.
Not like cancel out by it anymore. So that's the answer.
What are you doing? Will, you got it? Good
Oh,
job. Got it.
not
Got it.
cancel out.
Good job. No, 10 times the square root of 10. Yeah, just that's it. Nothing to cancel out, really. Okay, so your final answer here should be 10 times the square root of 10. 10 times the square root of 10. Good? Let's do another one. Come on. Let's keep rolling. Ready, go. There we go. Connor, you good? Got it? Got it? Well, it's upside down, but you're good. No problem. Got it. Got it. Did you get it? There we go, Joel and Luke. That's good. Yeah, not so good. Yeah, so what you did there is well, it's almost like you distributed the squared. We can never distribute a squared across a plus sign.
I see. So then it would be. I see.
That's all it is, yeah. So the squared and the square root would cancel.
Because you can't just take that out.
Yeah, you can't. Well, what you can't do, here's where you first went wrong.
Square root.
You wrote the
Cancel
square root
these out.
again.
You cannot do this.
You eliminated it.
That's essentially what you did.
No, without
Definitely cannot do that. You cannot distribute an exponent over a sum or a difference.
Emily, I'm gonna write some things and you're gonna
Okay, there we go. Lana, Hosanna, good job.
Don't look.
Nice job there. All right, looking pretty good. Did you guys get this?
Yeah.
3x plus 8.
Which hand do you think is my right hand?
I got one last one for you. Let's try this one. Please go slowly. Take your time. This one's a little more challenging, depending on how you do. No, sir. I'm sorry. That is correct. Yeah, you got it.
It's not 15.
It's a very fancy looking 45, I guess. Yes, that is right. Keep going back there. How we doing?
What's 9 times 5?
45.
Yeah, I think you're doing it.
How'd you get 10?
Oh, I meant 20.
Keep going.
Oh wait, I did it wrong. Hold on. I forgot to put my.
That's right. This looks almost like a minus sign. Is it just like a squished times sign? Okay. That's good. That's good. So let me show you a solution. Those are good numbers back there. Oh, the one on the left. So, hey guys, listen up, please. Listen up. This could be the most challenging one for the day. This one is always a challenging topic. Let me show you a couple ways to do this. I really like this way right here. Hold on. So squared, doesn't squared simply mean times itself?
Yes, sir.
So if you wanted to, you could just do this. You could write 3 square root of 5 times 3 square root of 5. And that would actually turn it into a more simple version like we did earlier today. If you were going to multiply those together, you'd multiply the 3's together and get 9. The square root of 5's get multiplied together to be square root of 25. And we know that the square root of 25 is 5. So 9 times 5 is 45. It's a little bit of a longer way to get there, but it's pretty reliable. It's very reliable. Here's another way you could do it. You could look at this, and you could use, from chapter 5, the old power of a product rule, and you could say that this squared applies to both factors inside the parentheses there. And if you did that, you would get 3 squared times root 5 squared. The folks that got 15, I think that you got this part right, but I think you forgot that the 3 would need to be squared as well. And so just be on the lookout for that. This way it works. 3 squared is 9. Square root of 5 squared is 5. And of course you end up with 45. You could take either approach there, and I think it would work out great for you. Just make sure that what you do has a good math reason, right? That you're actually doing what the squared tells you to do. And if you start there, obviously you guys know how to do the arithmetic and you'll be fine. Okay? Guys have any questions at all? Okay, so Haley, you need to depart, and you can just stay departed. You take your stuff with you if you want, or you can stay out in the hall. But either way.